Let me begin by introducing myself first. My name is Ayushi Jain, and I am the Associate Manager within the Learning Operations team at Udacity. Currently, I'm supporting two schools, the School of Programming and the School of AI. And today, I would like to welcome Thiago Grabe, the speaker of this session with us. He is also a mentor at Udacity, who has been actively reviewing numerous AI and programming projects, and he has contributed immensely to the content updates as well. Thiago is also a renowned speaker at Udacity, as he has delivered multiple insightful sessions last year on topics such as the role of vector databases and RAG systems, and agentic AI patterns and frameworks. So today he is here to share with us insights on why agentic AI projects often fail when they are transitioning from proof of concept to production. So before we start this webinar, I would like to share that this is being recorded. Additionally, if there are any questions, we'll take up at the end. We already have some questions from the audience, so please allow us to answer them at the end of the session. So without any further ado, I'll hand it over to Thiago.
Yeah, thank you, Ayushi. Hello, everyone. It's a pleasure to be here again to talk to you all. Today, we are going to talk to discuss how we can move agentic and generative AI solutions from POC to production ready. So it's a challenge. It's going to be, as you we will all see, it's going to be technical and also for leaders to have a perspective how we can address those POCs and make them to production. So this is the idea. Let me introduce myself. So Ayushi already did that nicely. So just a few highlights here from my side. So been working as a machine learning engineer and data scientist for several companies from the last 8, 9 years. So it's been a great journey so far. Currently, I help organizations to architect, deploy, build solutions from traditional machine learning to agentic solutions into different business, different environments. So it's been a journey. It's been a great journey so far. And at Udacity, it's our pleasure to be here with you all. Well, so before we start the content, let's unroll the agenda, what we will cover today, and a few housekeeping things to mention. As you probably saw, there is a chat button on your right button at the bottom of your screen. Use that to chat, and there is also the Q&A part where we can fire questions during this audience during this 1 hour, and also the poll where you're gonna see we're gonna have two quizzes here, two polls where we try to interact, try to think about two study cases here, and there will be some options. So let's engage there as well. So Q&A for questions and the poll part for these two questions. Okay. So what we will cover today, what we are going to discuss today. So there will be 5 sections, and I want to tell a story. So what's happening in the market, what's going wrong, and how to fix it technically, not too deep in technical, but overall, and how organizations can structure themselves to do next. What is the best for these agentic solutions? So there will be 2 parts. One more technical when we are going to discuss about some pieces of architectural designs, but also some organizational section. And I'll try to speak here for different roles: engineers, IT leaders, and business leaders. So each one of you have your own responsibilities to make organizations work properly, and I want to be specific for each kind of persona here. So oftentimes you're gonna see me being directly speaking to engineers, to IT leaders, to business leaders, and that's intentional because I want to catch attention to how I believe and how I have seen those projects going to production and be successful. And this is not only engineering work; it has to be an organizational structure to allow this. And this brings us to the call out here. So strategy precedes architecture, and architecture precedes code. But none of that matter if we are not aligned in ownership, governance, and also success metrics. All right. So we're gonna go through what's going on now, agentic architecture patterns and organizational readiness. Let's move on. So what is going on right now? Why I would like to bring this information to you and why this is relevant. So a few numbers here to make this agentic landscape for this year and maybe for 2027. So 74% of companies plan to deploy agentic AI within the next 2 years, and this is huge. But 21%, one out of five organizations, maybe have the mature governance model to actually deploy. So we are talking about one in five companies who actually have the right infrastructure, the right governance to deploy those projects. And what we have seen from different articles, from different studies, is we have the money to do that. We have the appetite from the organizations to do those projects. And by the way, we have the capability, we have the engineers, we have the technology, we have the LLMs to do so. But in fact, what's happening is sometimes we are losing along the way the connection between the technical part and the organization part. How we make the governance better to come from the proof of concept, from demos to production ready systems. So the technology isn't the bottleneck anymore for most of the cases. Strategy, governance, maybe it's the are the bottlenecks that we are going to discuss in the next few slides. So, and that's maybe true if you're writing agent, building a platform, or any other initiative, but we are going to focus on agentic solutions. Having that said, I like to think about uh, agentic solutions in these frameworks where we have different rings here, which represents uh, perspectives of how we implement those systems. The outer ring here, we can think about the multi-agent systems, multiple specialized agents coordinating themselves to solve complex tasks here. We have highest capability here because we can address different personas, different uh, types of work here, but it's also operational, really complex to manage all of those agents. And honestly, maybe a few enterprise right now can handle with multi agents and have the right infrastructure to run them the right way. The middle ring is the single agents with tools. So one large language model reasoning in a loop, calling tools as needed. This is good for well-scoped tasks. So imagine that you have a specific task and you know how to do it and you want to somehow automate, somehow to add the reasoning on top of that. So this is a good call. But the real risk here is we can make unpredictable costs. We can run into infinite loops here if you're not taking the right decisions. So, but this is also a good one. This is less complex than multi-agent. We have to take some extra caution with some things. Most important thing here is the inner ring. So this is where I want you to call your attention because it's workflow with AI nodes. So instead of thinking about agents, autonomy, let's think about workflows. Let's think about how we can define a structure, a procedure, and in specific parts of the process, we introduce AI nodes. So deterministic orchestrations where specific steps uses LLM to reason. Most of the production ready systems actually work this way. We have a specific workflow for data, information, and we can think about adding AI nodes to reason. It's more predictable, it's more auditable, and it's debuggable when we work with workflows. Yeah, maybe for engineers in the room, the inner ring isn't that boring. So designing or thinking or architecting how to add AI nodes in deterministic workflows, or how to think about, hey, how can I add AI into our current system? This is a good challenge, and this is a genuine hard work to do. So we have to really think about it, and this is where the craft really is. Maybe for leaders, what I would like to say is this is where the reliable ROI is. So we have a structured workflow. We know how things are going, and we put specific AI nodes to extract the most from our systems. So this is a framework, or this is a spectrum that I like to show and to put emphasis on the workflow with AI nodes, and maybe the single agent with those, if you have the capability, if your organization are more in structure in terms of that. So having that said, having this these nuances, having this perspective of how AI is and the different systems that we can build, let's actually discuss the POC trap. So let's deep dive a bit into why those proof of concepts sometimes fail, and so how these proof of concepts are successful in one way, but when it comes to production, it fails. And we start with four main things here. And I would like to separate these four gaps uh, into different columns here and make a deep dive into each one of them. So maybe when we are designing proof of concepts, we skip a lot of steps that actual system, actual softwares use at production level, because we want only to prove the concept. We want to make sure our LLM, our agent, the piece of software, the piece of code that we are writing will be able to solve one business problem. And that's good. That's what the proof of concept is meant for. But on the other hand, on the other side of this discussion, we have specific things that we have to take extra care when we go to production. First one, the first card, the first column is the guardrails and authentication. So the demo run without any issue when one user, the developer or the development team. So no permission issues. We have access to the database. No PII filtering. Why? We are dealing with internal developers. But productions sometimes means multi-tenant access control, content filtering, and scope boundaries. So this is really, really important. When you go to production, guardrails and out, it's simple for most of the systems, but guardrails here from agentic systems, AI systems, is a little bit different from the usual software guardrails here. We are dealing with different scenarios here. Card two, or the second column, now we're gonna discuss about cost, or how we control the costs. And sometimes the demo or the proof of concept has no a tight budget, or the budget is quite okay to develop whatever we have to develop. But in reality, when we go to production, when we have to scale things, if we are not designing the agent the way it is, or we are not designing our system the way it should, our agents can enter in infinite loops, or if we're not dealing with retry, we can also spend hundred or thousand of dollars in API calls without the proper answer. So cost controls are really important when we are scaling our systems, and of course, adding circuit breakers, validations are important here when we're discussing about moving from POC to production. The third part here is, again, we have for non-softwares, maybe it's in place in most of our organizations for the softwares that are running, but for the agentic systems, this is not different. So we have to put in place observability layer on top of that. So on the POC, maybe we have the team looking into the logs, understanding what's going on, but production really needs trace level logging, latency monitoring, and automated alerts when performance degrades. And performance might degrade. We might have some issues when we're dealing with different scenarios. And that's really, really important. We can even enter in edge cases where we need to understand, to improve, to iterate into the next phase of our development plan. The final one is the human escalation. Maybe this is not that obvious, uh, but demos or POCs implicitly has the human in the loop. We are watching what's going on, and the developer who is watching can take some actions to fix what's going on. But when in production, there will be thousands of requests, hundreds or thousands of users, and we need to have an explicit escalation path. When things will goes wrong, who is responsible? When the agent hits its confidential boundary, when we have an alert, who we should be talking to, who is responsible to understand what's going on, and how we can improve from there. So this is really important here. And maybe for engineers, those are topics who is really intuitive. This is given. We have to add in any software that we are writing. But agentic or LLMs projects has one particular part, which is the POC sometimes prove the business needs, and we are kind of anxious to launch into production, and we can skip these details, and that's when it fails when it comes to production. So maybe leaders see a working demo and say, hey, can we deploy this next week and have it ready? But yeah, we have to take care of these topics because these are part of the equation. So I have said some stuff about what the POC has and what production really needs. So let's think about this case study here. This is a scenario. So this is a multi-agent trip planner. So we're kind of designing this multi-agent system here. So it's specialized in agents for finding flights, finding hotels, finding activities in the destination where we want to be, and budget coordination. So we have a budget, we have a destination. Yeah, find me flights, find me hotels where I can use, right? So sometimes the demo here or the POC will take a week with a specific set of data. You put natural language in, so you type plain English, and then you get the itinerary out with everything you need. And the goal sounds great, right? So what we can do from now, hey, this is took a week for us. Let's ship new features every week. Let's use the latest models. Why not? Let's use what we have the best in the market. No token limit. Come on, it's working fine. Let's use what we have. We are heavy AI developers. We don't have to take care about tokens. Let's use it. And what we have, our goal is to have at least 10K users. So this multi-agent is looking great from the POC, but let's deep dive and let's look into a bit of details or some details of the same perspective, the same project, but from a production perspective. So shipping to more than 10K users. So we have to solve a few things here. Rate limited per session. So how that's going to work for per user. PII handling for passport data, payment data. We didn't care about it in the POC because the data was there. Fallback behavior when the agent doesn't do the plan the way it does. What it happens when the budget does not allow the flights available. What are the cost controls for API calls? What are the quality evaluations? So, as I mentioned, the demo or the POC can take a week, but when it goes to production, maybe we should have a half year work or even less to make that ready into production. Because this is not only designing the LLM part, the agent part, and prompt engineering and context engineering. It's a system that should be in place with all the other things that needs to build a reliable system in production. So this is a case study, and then the core problem here. Demos or proof of concepts demonstrate capability, not readiness. And this is really, really important because when a POC works, leadership assumes that the hard part is done. They sponsorship the project, set aggressive timelines, and everything looks amazing. But engineers know that better, that they don't always have the organizational leverage to push back effectively because we have to ship as fast as possible, right? The demo validates that the LLM can reason about a task, but it says nothing or really little about edge cases, failure recovery, cost bounds, and quality at scale. Those are things that we need to take extra care, extra attention while developing so we can start iterating, shipping new features, shipping what is needed to get a reliable production ready piece of software. This false confidence that the POC create and premature celebration leads to these aggressive timelines under resourcer teams. So this is pain when we don't have the resources to actually build what we have to build, and then what is a success demo or success proof of concept can become a problem during the development phase, and that leads to this 40% projects that we will cancel along the way. Really important things here that this is not theoretical. This is happening right now. And let me bring a few examples here of things that are failing or failure in the past, which with extra care, maybe we could have a better way here. So these are real cases or examples that agentic systems or generative AI projects that have somehow issues either with data exposure, PII data, API keys exposure, or other stuff that happened that yeah made this project not that reliable. I'm calling out here for Microsoft Copilot. So we have a leakage in the email. So they could somehow trigger Copilot to steal organization data with no user action at all. Actually, OpenAI also already is bugged to expose their other users' chat titles, names, emails. I put a link for those cases or bad examples. So you can later on, when you get the presentation, you can read the entire post-mortem or article to understand what's going on here, and you can learn from these mistakes. But let me ask you, where is your or where does your organization sit today? So maybe exploring, maybe prototyping, maybe piloting, or you are even scaling. So your organization are somehow in one of the three seats, one of these four seats here, and it's a reflection to be made. Are we ready to the next step, or are we good? Are we comfortable with the way we are today? So let's leverage so we can keep going to the next phase. Those are a reflection that I would like to bring here. So we have this perspective. Let's discuss some architecture patterns that actually ship. Right. When I mention here that actually ship, so these are common architecture ways of building these systems. Of course, this here I put in a single slide, so we have a lot in depth to discuss if we enter in details of each one of them. But in a nutshell, these are what I see the four patterns arranged from simplest to the most complex one that can help you to to help your organization from the four layers we have seen, from prototyping, creating POCs to the production. The first one, workflow first. It's deterministic, it's predictable. So we have DAGs, we have DAGs and state machines with LLM nodes at specific steps. So this is really good for regulated industries where you have to have really control of every step of your system. So you still want to take advantage of uh, of some AI or any machine learning step, but still you have control of everything. The column two, or the second one, is the agent assisted workflow. And maybe this is the sweet spot here because we can combine the workflow with agent solutions. So deterministic orchestration, but the agent handle the ambiguous step. Human in the loop can be used for decision points to take specific decisions that are really important. And yeah, this is where I see the most majority of use cases going to production. A well-defined workflow with AI nodes dealing with specific tasks to reason and make some decisions along the way using the human in the loop when possible. The third column, so it's the single agent, one LLM calling different tools, maybe using the React pattern here. So this is a good for well-defined tasks as well. But here, one of the things that we have to take care is as we are dealing with agent, we have to add cost control circuit breakers because unbounded loops yeah, can cause extra costs, and we don't want that. So single agent is more autonomous, but it's scoped. We have a defined scope to run this agent. And finally, the multi-agent, uh, which is the fourth column. This is the maybe what we have in more complex here. So we're talking about coordination. We are talking about complex tasks here. This is powerful for tasks that we can decompose somehow. So we have a huge business request, but we can decompose those tasks and add agents for each one of these tasks. This is one way of doing that. But thinking about having different agents, one failure on the first agent can cascade this error from the next one, and this error can be propagated along the way. So it's really important that this type of architecture are really impressive. Is really powerful, but it's complex and it needs a lot of extra care when evaluating, making sure of each agent are doing what they have to do. Maybe for the engineers here on the room, the column two is where the most impactful work is right now. So finding where to add AI into the existing systems. So and this is not easy. So choosing where to set LLM reason into deterministic workflows, it's harder than it seems, but it really pays off when we find the right spot. As I mentioned, this is a sweet spot. And for leaders, maybe this is the fastest. This is the low hanging fruits here because we already have our system. Maybe we're finding specific parts of it, specific nodes to add AI and collect the gains here. So these are the perspective of what I think it really works when we are designing agentic systems. But also let's pay attention what can break from each one of these, because the failure modes uh, are really important to highlight when we're choosing these architectures. So a few examples here. So 6 production failure modes that I see the most, and it's important to keep an eye on it when we're developing. So infinite loops, so agent retry fail it without a backoff, latency spikes. Maybe in the POC we are dealing or we are not handling any difficulties because yeah, our providers can support a lot more, but and our system can support a lot more. But when you're going to production, how to scale those things. Cascading failures, I just mentioned when you are dealing with multi-agent systems, maybe one failure in one agent can propagate, and how we handle with that, how we can evaluate, how we can isolate those kind of errors. This is important. Cost explosion, we already mentioned the tokens usage and how we can address putting constrained loops so we do not explode, we do not call our LLM vendors in excess, so the costs are under control. constant context window overflow. This is maybe well known. So when we implode our context window with a lot of context more than needed, and our systems sometimes start to hallucinate, giving the wrong answers, or maybe break because we don't have more space there. So these are also um, possible failure modes that can happen, and having an eye on it, taking care of it during the development is really important. And also the engineers here on this room, they recognize most of these issues. So yeah, latency, come on, this is given, we have to take care of it. But those your leaders do your leaders knows about it, specifically in agentic systems. We are talking about latency. The latency for a common piece of software is different from a latency of LLM response. So these are different scenarios, the same issue, different scenarios that we have to be aware of. And for the leaders here, maybe when your engineering team asks for a few more weeks or one more sprint to take care of specific things that maybe are not features or business features, but are designed to make the system more reliable, this is where you should be listening to them, right? Yeah. Finally, here, myth against reality. A few things that also we might hear during the development, and three myths that I think it's really, one of them is really, really important. It's the first one because uh, every 6 months, if not every month, we hear, hey, this is the latest model, this is the best model right now that we have, and maybe we are kind of anxious, hey, let's test this in our application. But maybe we don't need the latest model, we need the model that works for our system. And by the way, the cheapest one. That's how we increase our ROI, solve the business problem with the best model with the lowest cost. And that's one way of thinking about that. Another myth is agents should be fully autonomous. Not at all. The most successful production agents have really narrow scopes. They do what they have to do, and they do not overthink about specific tasks. And autonomy is something that can be earned incrementally. So we can, from time to time, increase this agent's responsibilities, and also how we improve the system as a whole. Finally, multi-agent systems are always better. Maybe not. As I was mentioning, it brings a lot of complexity, and a lot of failure modes can happen because we are using multi-agent systems. And maybe what we need to do is just work with a workflow, a well-defined workflow with the business team, define the steps that we have to take, and planting or adding agentic nodes on it. So complexity is not a feature. What we need to do is solve a business problem using the right tool. So architecture gets you 50%. That's the message here. So uh, we can think about the right architecture, we can think about the right stack, we can um, address the failure modes, we can even discuss the myth that I just spoke it. But architecture gets you 50%, organization gets you to production. So more projects here die from organization dysfunction than from a bad architecture. And what comes next here is the organization model. So until now, we spoke about specific nuances um, of architecture, failure mode, observability, and stuff like that. But from now on, during this presentation, I will be addressing, hey, how we can wrap up this together to our leaders, so they can um, they can be aware of their decisions and how this is impact the development team, how this is impact the organizations. So the engineers don't turn out. The sections determines whether your work reaches production or not, because this is how the leader should perceive, should see uh, the next phases of these products. So questions like who owns the agent, who is accountable when it fails, and how IT leadership can address or can support the teams. These are things that we're going to discuss from now on. Before we moving to this one, that's where we come to one case study, the pricing agent trap. So this is a case study. This is kind of scenario. Imagine that we have one specific scenario, and we have to determine if this project will succeed or fail into production. So a major logistic firm implements a multi-agent system for dynamic pricing across 5,000 daily routes. The goal, 15% margin improvement, $5 million in annual savings. This is a good project. They pick a multi-agent architecture from the start, use the latest model because they want to be ahead, but they skip cost controls, circuit breakers, unbounded retries to guarantee the pricing coverage. Will this project succeed in production or fail? We have four options here. Now you can go to the poll part right in the side of the chat there and answer the question, reason about it, think about it. Let's give you a few seconds and let's move on. A, fail because choosing multi-agent architecture is too complex and most successful systems are agent assistant workflows. Yeah, promising. B, succeed because business problem has a high ROI. So if I put ROI 5 million, 10 million, the most ROI, the more likely to be successful. This is what B is saying. C, fail because the lack of circuit breakers and unlimited retries will lead to a cost explosion. Infinite loops can burn thousands of API budget, promising as well. And D, succeed because the architecture is relevant if models are capable and the bottleneck is engineering, not intelligence. All right. So I hope everyone had the chance to answer. And the right choice is C. So it will fail, right? Because of the lack of circuit breakers. So they kind of skip it guardrails. Yeah, they just using a lack of circuit breakers. They are using multi-agent systems without taking care of these specific things. When I mentioned the myth slide, complexity is not a feature. So using multi-agent systems from the starting point, maybe it's not the best choice. And they didn't take care of infinite loops. And yeah, this is the most common killer for pricing, for cost in projects. So let's move on. Organization readiness and governance. And we start with a question: who owns the agent? So that's maybe the question to be answered. So agent cross team boundaries, right? So one agent will use data from supply chain, but it will reason from for finance. It can also use other types of data to reason, but respond to other teams. So this is hard. Platform owns the infrastructure, product owns the UX, the legal will care about the compliance of this system. But if no single team owns the agent behavior, and that's going to be a lack of governance in our project. One of the solutions that we have is to have one specific persona in the project. It cannot be one you hire. It can be a person from the team, but the solution, or at least one of the models that we have, is the agent product owner, right? Someone who bridges or who put together the technical and the business perspective. He or she can talk about both sides of the equation here. Who owns the agent behavior, the performance, and the compliance? So as I was mentioning, this person will be responsible for bridging this gap. For engineers, what I have to say is this person must be your best ally in this journey while building the agents, because they will translate business requests, business or use cases into what you actually have to build. So this is one of the things, or one of the models that really helps. And we have to think about these agents, or at organizational level, we have to think about this agent as an employee metaphor. So stop it thinking about this agent as just a piece of software. It's not only a piece of software, right? This is can be seen as a real or a new employee. You wouldn't hire an employee and give them access to everything, to the databases, and walk away and forget about it. So you have to define the role, you have to onboard, you have to scope what they can do and what they cannot do, and also supervise the work, and finally review the performance. This is what we do with some new employee, but also what we should be doing with agentic systems here. And for IT leaders, your mandate here maybe is to help uh, the development team, the engineers, is I separated here in maybe in four specific parts. Build a platform, centralize the foundation, so reusability, LLM gateway, things that can be used to speed up the development. On the observability end to end. So this is observability. This is typically engineering tasks. So on this part, make this accessible for different projects where you can track cost, latency, and quality per agent. We can define the security perimeter for each agent. So we can scope the permissions for each agent to make sure each agent is doing what it means to be doing, from tool invocation, reasoning. So we can use the same rigor as we use for our EIM policies. Four, establish evaluation pipelines. We all have ways to evaluate our systems, from unit tests to integration tasks. That happens for agentic solutions as well. We can add a few regression tasks. We can add LLM as a judge. We can improve the cost benchmarks along the way, and we also can implement harness into our system to make it more reliable. And this is should be sponsored by the leadership, because it can be reused in different projects. It can be built upon a platform. So it's really important that the leadership sponsor these things here. On the other hand, or from the business leader's perspective, a few things, or four things important here is on the use case selection. Not every process should be agentic. Not every process needs AI to be done. Uh, but owning your own use cases and how you select the use cases are really, really important. So ROI when building these business cases and developing them are not the only metric. We have other metrics to be uh, taking care during this process. For example, how we put our current business team to support and to help the development. They own, or they know how the business run, how we can use their knowledge, how we can make them part of it, to make sure, one, they are engaged, they know that this system will help on specific tasks, and how we valuable them for their knowledge. So establishing a governance model is really important, and communicating to the business team is also what brings value and what brings the team towards the same goal, which is deploy correctly and have these projects ready. So maybe a cross-functional agent squad here. So this is kind of personas and people that can help along the way. The agent product owner, the ML and platform engineer can help you defining the business and making the bridge IT and the business. The platform engineer can maintains the agent and know the best integrations and the best evaluations pipeline, and also the domain expert. So this is the person who define the expected behavior, validate outputs. These can be this persona or this person can come from the business team who actually knows the process that we are trying to automate, or we are trying to use AI to develop, right? So these are important things regarding um, the governance layer that I would like to talk here. Um, Maybe one of the common mistake when I look into those persons is making the machine learning engineer, making the AI engineer responsible for bridging this gap between the business and the technical team. It can work. This can be this persona, but we should have this platform engineer apart with their own responsibilities. This is an important call out here. Having that said, let's make our second quiz here. We are going towards our final part of the presentation. So this is more organizational this time. So picture this scenario. It's a financial firm. Its project, their project, wants to be deployed uh, in the given architecture. So it's an agent with high volume contract for be to be reviewed. So we have a conflict here because the business team and the machine learning team cannot agree on the agent success metric, the cost limits, and the accountability. So when it misbehaves, who should be accountable for? And this situation demonstrates the core governance failure of agents crossing traditional team boundaries. So the question here is, which new defined role is necessary to bridge the machine learning and business teams by owning the agent's performance? So we have A, B, C, and D, different personas, different positions that can be used to fill this gap. So CIO, maybe the domain expert should be owning this. The APO, the agent product owner, can be one, or the machine learning or platform engineer. This is the guy, this is the woman that should be doing that. So 30 seconds. All right. Yeah, maybe this is easy. We spoke a lot about the APO, so the agent product owner. Again, this persona or this specific new people in the team should be the responsible for bridging this gap, keeping the domain expert, keeping the machine learning or the platform engineer focused on their own roles and not overlapping responsibilities is a key thing to win in those projects. Of course, not every time this is possible, but maybe identifying people in the business team who can understand the technical part, or the other way around, technical people that really can address business problem and putting this person in this position. Maybe it's a good way out of having this APO in those projects. Okay, finally, what is the suggestion roadmap? How we can have, or how can we start tomorrow thinking about what we discussed here? This is what it meant for. So, which process are candidate for agentic AI? What I can tell you from my experience is start simple, low complexity, low cost of failure. So start automating process, and then you go to agentic assisted project with high complexity but low cost of failure, right? So start increasing the complexity. Thinking about as a third step the human in the loop, if required or not, because the human in the loop will add some kind of latency in these projects, but also can be helpful for specific types of project like financial approvals, compliancy, customer facing communications. So these are important things. And maybe there are things that are not ready yet because it's too complex. The cost of failure is too high, and maybe we have to think about how we can make this agentic or these problems solved with the agents. Maybe adding the human in the loop would be the uh, one solution, but maybe there are specific type of projects which are not well, or they are not ready to be designed. We also have some governance anti-patterns here. The shadow agent, the committee of no, the handoff spiral. Those are things that maybe can kill the project before it goes to production. And the committee of no is something that really I personally, I really have been facing difficult situation with that because, yeah, the governance becomes the bottleneck of these agent solutions. Maybe we need six approval, and one of them are not allowed with the way things are going, and we get stuck because of these things. So the key message here is over communicate, bring everyone to the table, maybe put different departments part of the solution. And yeah, this is piece of advices and pieces of things that I would be doing next in different projects here. Uh, Predictional readiness loop, it's maybe linked to how we prioritize our our projects here, but audit, architect, organize, and iterate. So keep iterating, always put the business needs in front of technical designs. Maybe we should be keeping simple in the first, in the second iteration, and only then adding layers of complexity. So following this strategy can be a game changer here. Well, and as a final message here, three things to remember which makes total difference. Strategy first. So strategy precedes architecture, and architecture precedes code. So is your organization ready to deploy those projects? Second one, earn your complexity. Business leaders, you should be the ones who make the tone or what should be done next. But the complexity uh, should be improved from every iteration. And agents are organizational and not just technical. So who will be the owner of this agent when it fails? Who will make the tone for what are the success metrics? What are things that we can say, hey, this agent is really solving a business problem? These are the three things to remember. A few takeaways from this presentation. Um, from the technical part in the initial part of this presentation to the more organizational part here, the second half. I hope you had a chance to get this perspective and reflect how your organization is right now.
Amazing. Thank you so much, Thiago, for the incredible session. I think your session catered to every type of audience and resonated with participants across different backgrounds and experience levels. So, thank you so much. And we're going to open the floor for the Q&A session. But before that, I'd like to highlight that for the Agentic AI Nano Degree program, Udacity has started a 7-day new 7-day trial. This is free for all, which includes full access to 50 plus learners lessons plus opportunity to build and submit 4 portfolio ready projects, and you will get personalized feedback from mentors as well. So yeah, you can start learning for free today. Yeah, let's go for the 10 minutes Q&A that we have right now. Thiago, do you have questions ready with you so that you can just read out the questions and the answers as well?
Yeah, so I have a few questions up front from the audience. So, what is the right first use case to use, and how we can identify that? So, this is a common one. So, we covered that in one of the slides, which I recommend is go to automating specific process that you know well how it works, and you could evaluate just looking at it. So use the best judgment to identify process that can be automated. Start gaining knowledge how to build workflows, how to build agents, and starting from there. That's my way of thinking how we can uh, easily start using AI in the organizations. Maybe a second one, maybe more technical. Which framework should we use? it depends on the different organizations. We have different contracts with different cloud vendors, with different LLM providers. Maybe your entire, maybe we're talking about an e-commerce or you're talking about a retail, and the whole stack is built in a different programming language. So maybe you have to agree how to deploy one Python or one Go or one Rust application. I don't know, but which framework will depend on your organization contracts and knowledge how to deploy stuff. But as always, there are new things to be learned, new things to be implemented. And my suggestion, what I would do if I would be starting, LangGraph for agents, it's a good one. Google ADK is also a good one. And I think the both nanodegrees cover these ones as well. And yeah, this is my tips. Not sure if you have live questions here so we can address. Okay. Yeah, one question that I'm seeing here is about hallucinations and how we can address maybe a few things about hallucinations and context engineering here. So one of the things that I typically see is most of the LLMs don't have visibility, or they weren't trained in the data that we have available. Maybe we have internal data. The data is not available for the vendors to train their models, and we can use RAG systems to add the context into the prompts of these agents so they can reason about the instructions and also the context of what we have for our internal data. This is one of way of giving power or giving access to agents with our context. Another way is giving agent access to our databases, either relational or non-relational databases, so they can actually query things using specific tools for that. So those are different things how we can leverage better context to our agents, and depending on the strategy can be specific agents that can query databases with the drawbacks having the access to that, or using the RAG with specific uh, databases or vector databases.
Amazing.
So
Thank you so much, Thiago, for answering the questions. There is a feedback form that I'm attaching in the chat with the link. So feel free to provide us the feedback for the session. We'd be happy to hear it. Thank you so much, everyone, for joining.
thank you all. Thank you for your time.